Good afternoon. Thank you for the invitation. I'm from São Paulo State University. I lead a group on nanobionics. Indeed, my field is physical chemistry, theoretical physical chemistry, but we decided to use the approach we use in physical chemistry to diagnostics. I will tell you not only about dengue, but the concept of a new platform we have developed. We call it electrochemical capacitance, but is indeed an electrochemical method that uses specific signals of impedance of one interface. So the idea is that my research field is in electronics and electrochemistry, and the idea is how to connect these two different fields that are similar but not so close. We have been proved that we are proving that electrochemics and electronics are more similar than we think, and so this becomes very interesting for diagnostic because, as you know, miniaturization of electronics has been successful. And what limits the miniaturization of devices are indeed the battery, which is electrochemistry anyway. So, and everything is based on transistors. So transistors is a concept very interesting. On the other side, you have all the electrochemistry being used, and we can see some no successful but ideas that is coming to the market. The idea is always using molecular modified electrodes or modified electrodes with molecules, and if you are able to control the electronic properties of the interface, so you can have more successful in identify or diagnostic any kind of things. I will show you to you here really a platform we have been developed. So the ideal case is listed here. No, you have the ideal situation we aim to. Obviously, there are difficulties, but we have been successful in doing this. So let me explain how we are creating a new platform based on electrochemistry. The idea is to make a transistor using the characteristics of the molecules you have on the interface, and you can modify this interface with your target. So the idea is to connect the electronic properties of your target with the electronic properties of your molecule you designed for that. So in this case, you have a transistor characteristics or a capacitance of this interface that is quantized, or we use quantum mechanics effects that is very sensitive, because then any kind of modifications you have on the interface, you can really target and be able to detect. So I will not enter on the discussion of the science. I will just tell you how more or less this works. So the idea is that, as you can see on the picture, is that we can, with the signal, this is a spectroscopic signal, electronic spectroscopic signal, which we can separate between no specific and specific bindings. So we can design or target to have a background signal where you can subtract no specific signal, and then purify the signal to have only the specific signal that we can manage. So this gives us a very, very accurate electronic signal of the interface you designed to. So indeed, it's like more or less a picture of what we did. So we mixed our molecules we designed with the antibody. Then one antibody is an example of our target that can be used. Then we can capture very sensitively any kind of target. The platform has different ways to operate. We can operate indeed as a very, very specific transistor characteristics, or an open transistor or short circuit transistor. So it depends on how you design the interface. But what is important is that it can be multiplexable, miniaturized, and here is an example of the sensitivity we have. In this case, we are measuring, because the capacitance is associated with the energy, we are really measuring any kind of electrochemical or electrical plus chemical energy of the interface. So if it changes specifically on the target, on your receptor, we can track, and this is analytical curves, very well constructed in totally blood serum. Okay, this is the specificity we have been reached. This work we started a few years ago. Part of our technology was licensed to. We have made cooperation with Oxford University. Part of the technology is now fully licensed by a company. I'm the founder of the company here in the UK with the partners in Oxford University, and we have been testing this clinically. So this is really a new platform for diagnostic. To compare with more or less what we have been done in literature, we are located here with a label-free capability. Obviously, we can also work on the label platform if desired. Indeed, we are exploring all the capabilities of the signal. The company we founded is Oxford Osler. In our first moment, it was impedance diagnostic, Oxford Impedance Diagnostic, but now the company changed the name. Now it's Osler Diagnostic. And we have been working in different markers. We have been working with cardiac markers, cancer, prostate. The levels of sensitivity we have been achieved is between nanomolar to femtomolar, very specific. Okay, so I tested this particularly interested. I tested this in NS1 dengue fever. At this moment, I'm leading a project which is we are capable of diagnostic dengue, but we want to do it in a different way. We want to make it specific, which means NS1 is not a specific protein. So this is the problem of the receptor. This is the problem of our receptor, not of the target. So NS1 is not a very good receptor. We are now designing specific affirmers to differentiate between dengue, Zika, and chikungunya. The idea is to make a surveillance system in South America. We need to start small, obviously, but we are partnering with National Health and Medical System in Brazil. And this is not of the company. This is from my laboratory. The company is very advanced. They are miniaturized ELISA system. So at this moment we have a device which is the size can do any kind of ELISA in the size of a mobile phone. Okay, but the problem is still not good for. It's good for to substitute utilizing laboratories, but not good for field. So if we're going to dengue, we need to make it cheap. So this is because this is what I'm now working in designing more cheap devices for the platform, and also working on the electronic to make it cheap. But we think that if we are able to do the cheap and expensive, the device is not a problem because we can bring samples and do in a local in Brazil, we have different medical assistants, so we can bring this to some center and make the surveillance system to work. We believe this will be possible. It's still science development, but at the same time we are going to the business side. So thank you for your attention, and I'll be open for questions.